Hi guys, this is Dmitry, and today we're gonna do another troubleshooting lab, this time about IGP redistribution. As previous ones, this lab was also designed by Andre Laurent for his webinar session. The link for those sessions you will find below. Also you will find the link to the post-webinar discussion thread where we discuss some solutions and tickets. So let's start. So here are our topology, here are our tickets. As you see, Andre created 5 of them, and I also decided to create 2 more, and so this one and this one. Here we have one ticket where we have to influence the path, and another one is this one here, where we should ping all IP addresses in the network from all devices. So I struck out ticket 4 because it was that from all devices we should be able to ping directly connected links and only loopback 0 interfaces. So for my ticket I decided, let's just try getting reachability for all IP addresses in the network. So instead of this one, we will be doing this one. Oh, sorry, this one. Okay, let's start. Let's start from the very beginning. You do not have access to configure R7. Make sure that the 77 network prefixes are reachable from all devices. So 77 networks are here, or R7, so they are from 1 to 10 /32. Okay. So the first thing I would go to R6 and verify. Well, because we don't have access to R7, I can't go there. So I will go to R6 and check if we learn about these prefixes. Alright, so let's go to R6. And I do show IP route. Okay, we see a lot of different prefixes. Here we are. So this is the prefixes I am interested in. Okay, so but here is something very interesting. Notice from where we are learning these prefixes. Alright, so from 1. So and 1 is here. Okay, so even though these prefixes are from R7, somehow we learned this from R1. Okay, so this is definitely the problem. Let's try to ping it. Can we ping? No, we can't. Okay. And if we do trace route, probably we will have loop. Okay, indeed we have loop. So we go to 16.1. We go to here, then we go to 114.4, this is here, then we go to 46.1. What is this? It seems that there is some IP address misconfigured. Okay, let me do this. Show IP alias pipe this address. Oops, sorry, forgot include. Okay, on R6 nothing, H1 nothing, R1, R2, R3. Oh, sorry, on R6 there is something. Sorry. So we have interface, and this is clearly wrong IP address. If you do show IP interface is brief, look at this. Okay, so this IP address is wrong. Let's change it. We go to interface e0.0.46 and to IP address 10.1.46.6 255 255 255.0 and okay. If we do trace route again, okay, it's still wrong. So, but at least it seems that we have right IP address. So let's check it. So we go here, back to 6, and we are looping. Okay, so why is that? Well, let me show you. So this prefix is a node from R7 with some metric. We don't know yet which one. Then this prefix is announced via RIP to R1 and R4. Remember, RIP ID is 120. This we have here, you see redistribution, two-way redistribution. So this route converts to OSPF E2 probably, or E1, I don't really know yet. Then this route goes here, and remember our SPF ID is 110, goes here. Then R4 or R1, it depends on the order of operation. So then this route, one of the RIP routes will be dismissed, and we will choose another one. We will choose OSPF one, and then this route, because there is two-way redistribution, this route will be fed back to RIP, and it will go to R6. Okay, so R6 could learn this route via RIP from redistributing route. So there are a couple different ways to do that. So we could change here redistribution metric, maybe I don't know, to 15 or to 16. So that, but we don't really know the metric from this route yet. Yeah, so we could change metric here in the redistribution point, but probably there is better solution. Why don't we use tagging, route tagging? So the idea is that if we redistribute route from RIP to SPF and it somehow goes to another router, this route is redistributed back. So here we are setting tag, maybe like when we're redistributing from RIP to SPF, tag 10. This route will be tagged with number 10, goes here, and here we say, okay, if we see the route with tag 10, we won't redistribute it. So that's the idea, so that this route is never redistributed, and we have to do the same thing in 2 points. This is probably the best solution when you have two-way redistribution in multiple points. It could help you to avoid a lot of different problems. So let's do that. Okay. Let me check one more thing. I want to check on R6 if we have RIP running here or not. So I do show IP protocols. I go back to the very end and I see here, sorry, 3 IP addresses. 147. So it seems alright to me. Okay. Okay, let's do route. Okay. I will do route checking in the text editor. So we create route map. Let's call it rip to OSPF, and we permit 10. If we redistribute routes from rip to OSPF, we set tag to 10. Okay, then if we have route map OSPF to rip permit what? Deny 10. We match tag 10 and we permit everything else. Permit 20. Okay, so if we redistribute from rip to SPF, we set tag 10. If we redistribute from SPF to rip, we deny all prefixes that are with this tag, and then we permit everything else. Let me go to R1 and R6, and I will just show round section router. What we have now: redistribute metric 1 subnets, redistribute to SPF1 metric 1, and on R4 show run section router. Okay, what do we have here? Distribute metric 1 subnets, redistribute to SPF1 metric 1. It's the same thing, okay. And I do this. Router rip, distribute OSPF1 metric 1 route map. So we redistribute from rip to OSPF, from OSPF to rip, and router OSPF1 redistribute rip metric 1 subnets, route map rip to OSPF. Okay, and yeah. Okay, let's apply this conf t, and same thing on R4. And I do clear IP route star and clear IP route star, and here clear IP route star, and now we wait. Show IP route rip. Okay. We learn routes, and they are from 7. Okay, let me go to R1. Show IP route 77.77.77.1. We go to 4, so we go like this. R4. We go to 6 and to 7. Okay, can we do trace route from R1? Trace route 77.77.77.1, and we can. We go to 4 to 6 to 7. Okay, seems fine. Okay. Let's do this. show IP route 77.77.77.1 on all routers. Do we have this route? Okay, on R5 we don't have this route. What if we show IP route? Okay, we don't have any IGP routes on R5. Okay, so seems strange. On R6 we do have routes. Okay, so it seems the problem there is in IGP segment. So let me do this. On R5 we show IP IGP neighbors. We have neighbor 2 and 3. You counted 0, so it seems alright. So let's go to R2 and R3, and we will be doing what? We will check redistribution on R2 and yes, verify redistribution on R2 and R3. We do this show run section router. Okay, router IGP 100. And we redistribute to SPF, but I don't see seed metric, so this is the problem. Okay, we do router IGP 100. Oh, sorry, no, router IGP 1000. Router IGP 100. We do what? And let me add this to our solution. Ticket 1 on R1 on R6 on R4 on R6. Wait a second. Interface is 00.46. And IP address 10.1.46.6. Okay. Now on R5. No, it was R2. We go on R2. Router IGP 100. Redistribute OSPF1 metric. Okay. 1000 kilobit per second. 200 microseconds delay, 255 reliability, 1 load, 1500 MTU. Okay. Oops. Sorry. Okay. On R5 we should be able to learn routes. Okay. Wow, we see routes. And let's go to R3 and verify if we also redistribute those routes on R3. Okay. We do show run section router. Router IGP 100 redistribute OSPF 11 router OSPF 1. Okay, so here process number is wrong. Okay. Conf t do this? I don't know. 1R3 router IGP 100, no. And we do redistribute OSPF1. Okay. Okay, if we on R5 do this, show IP IGP topology for 77.77.77.1 /32. Okay. We see that we learn this route from 2 and from 3 over serial. Here we see very high metric on serial. Here is lower, so we prefer path to 2. Okay. Show IP route again. Okay, we see all these prefixes. Now, but the question does not ask us to have these routes in the routing table, but make sure that these prefixes are reachable. So that's a different thing. So for that, I will create TCL script. TCL script, which will verify reachability to all these prefixes. I copied in secure CRT these IP addresses right now, and I do this. I open TCL shell and I do for loop for each IP, open bracket, copy this, and we do ping variable IP. Okay. Let's verify if we in the right mode right now. No devices. Okay. 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 Alright. On R6 there is problem. Is there only one problem? Yes, there is problem with 77.77.77.9. Okay, let's go to our we are on route 6 to shell quit. We show IP route for this. Okay, we go to 7, but we can't ping. Okay, so I don't know, is there any access list blocking? Show IP access list. Okay, we have 2 access lists, test and test2, and here we have 5 matches. Okay, let me do ping again for this prefix, sorry, for this IP. I do another ping again to verify if we're hitting that access list. Show access list. Okay, I see that there is now 10 matches. And it says permit, it does not say deny, so maybe, I don't know, there is some control plane policing or maybe PBR. So I do this, I do show run section test2. And I see my IP address, so this is in the route map somewhere. Show run section route map. I see local policies, so this is PPR, route map PPR permit 10. So if you match this access list, we set interface to null 0, thus blackholing traffic. Okay, so well, we could remove PBR or we could like modify this access list. I will modify this access list probably. So I do this IP access list extended test 2, and I do this 5 deny ICMP any hosts 77.77.77.9, and I will add this to the solution on R6 IP access list extended test2. Okay, so I inserted the sequence number 5, so thus we override this 10 sequence number. Okay, let's verify again. Can we ping? Okay, now we can ping. Okay. We will close the switch. If we will need it, I will open it again. Let's check TCL script one more time. So, okay, here all right. Okay, all right everywhere. So if it is not all right, some router will hang with, you know, ping timeout. So if it's all going fast, so this means that it's all right. So it seems to me that we solved this one. Make sure, let's go to ticket 2. Okay, make sure R6 only learns the even prefixes from 55.55.55.x from R5. Okay, so this is these prefixes we are talking about, and we want to learn even prefixes. Okay, how can we do that? So, well, there are also a million different ways to do that. So we could have here a distribute list here inbound, referring to prefix list, specifying all prefixes that we want. We could also solve this with standard access list, matching on the even if it's even or odd on parity, checking on parity. It can be done easily with access list. Well, not easily. It's not that easy if you see this in the first time. And I will probably choose this one, access list approach, because if we add more prefixes here, not only from 1 to 10, I don't want to change it manually. With access list we can define if we want to allow all even prefixes from this range, even if we add more later. Okay, we could do it with redistribute list here using access list or prefix list. We can do here on redistribution boundary. So if we redistribute it here, we will call route map and also will exclude these prefixes. So I will probably do on R6 via redistribute list. Inbound and matching start and ACL. I will also show you how this can be done using binary math. Okay. Okay, let's do this. So in distribute list we will have access list, and we have to choose which prefixes we will allow and which we won't. So probably I will block odd and permit everything else. Okay, I will block odd from this range. Okay, so let me do this. It will be on R6. Router rip. No, I will probably do it in the command line. Let me think for a second. Okay, first we will define access list here. IP access list standard R555, and we do this. We will deny auth prefixes. How can we do that? So remember that wildcard, we have 0 is match, 1 means do not care, okay? And we have to deny auth prefixes. So I do this. We will deny 55, 55, 55, and here careful, we have to deny auth. So I will show you this last octet in binary. So for zeros, okay, and we have to like define a proper wildcard. Okay, so remember this is here the last bit in wildcard. No, let me do this first. If we have prefix and here wildcard, okay, if we have like this means that we want match exactly .0, so we will match 55, 55, 55.0. Okay. Okay. Let me add this here. So with this we match exactly on this 55, 55, 55, exactly what we need to do. Then this last bit in wildcard. No, let me. Well, we have this X, so we want to match all prefixes, okay? So if we do 1111, this means that we will allow we will match any prefixes from 0 to 55, 55, 55.255. But we want to match only auth. Okay? If we change here to 0, what will happen? It says, okay, match this 7-bit, and here we have either 0 or 1. So we will have like this 8 zeros. Oh no, sorry. This one means that we don't care about this 7 bit, but this last bit should be always 0. So we will like match like this, like this. So this last bit will be fixed 0. So if we convert it to decimal, it will be .0. This one will be .2. This one will be .4. No, it's not. It's .8. Or no, it's .4. Okay, so you see that now we are matching all even prefixes, but we will have here deny, so we need to deny odd one. What if we change here this bit to 1? What does it mean? It means that this 7 bit we don't care about them, and this last bit should be always be 1. So this means like this. 1 0 0 0 0 1 0 0 0 like 10 1. So this last bit will be always 1. And this is match for dot 1 in decimal. This is match for dot 3. This is match for dot 5. So you see, now we are matching all odd prefixes. So this one is right. How we convert it to decimal? This will be dot 1, and this will be this one. So if we have all ones, it will be 255. If we have 1 0 here, it will be 254. Okay, and we need to permit any, because we want to only block odd prefixes and allow everything else. Okay, we go to our solutions, that here. Okay, I will go to R6. First, let me show you if we learn all these prefixes. Okay, you see we have all 1, 2, 3, 4, 5 till 10. Okay, we want to have only even prefixes from this. Okay, we define this access list. Now we go to router REAP and we distribute list up. Okay, R555 in. Okay, and I will add this to the solution as well. And on this, only on R6. No, I will just show IP route. Okay, we still learn all these prefixes. We have to clear routing table. Okay, you see that now we are learning only even prefixes. Let me show you access list hits. Okay, so you see we have here some matches and here matches. So this one is indeed working. Okay, let me do show IP route again. Okay, only even prefixes. So this one is solved. If the link between R2 and R5 goes down, make sure that R6 can still telnet to 5555. Okay, can we ping now? Can we ping 5555? We can. Can we telnet? Okay, we have connection refused by remote host. Let's check if we have telnet configured. So you see we can reach, but we can't telnet. We do show run section line VTY. Line VTY. Okay. We have login and transport input none. We don't have password or no login, so this is one problem. And we don't allow telnet. This is a second problem. Okay. Let me go to on R5, we do line BGY 04, no login, transport input, telnet. We should be able to telnet now, and we can. Okay, but the question asks if the link between R2 and R5 goes down. Okay, let's go to R2, conft int e00.25. We shut that link down, and we go to R6. Can we telnet again? Destination unreachable. Can we ping? Unreachable. If we traced 5555, sorry. We go to 1 and or 4. Then we don't have that prehex. Alright. So let me clear this diagram a little bit. We are telnetting to this IP address. This link goes down, so R3 should be able to announce this route to 5555. Let's check its routing table. We do show IP route 5555, and you see that, wow, it's directly connected. This is because there is an encapsulation type PPP on serial link, probably. If you do show interface serial 11, we have an encapsulation PPP. So because here is PPP, we learn this route is directly connected. Do we announce it into SPF on R3? How can we do that? We do show around section router. Under IGP, we don't have network statement for 5. We don't redistribute connected. And under router SPF, we don't redistribute connected. So this is the problem, because this route is learned via directly connected, and neither OSPF nor IGP is running on that interface. We can't announce it to others. So one solution would be like announce it to either IGP or SPF. Does not really matter. But here I have another solution, probably more elegant in this scenario. So in PPP you can disable this directly connected behavior. Okay, how can we do that? We go to serial interface and we do no peer neighbor route. Okay, this one. And we have to initiate a PPP session again. We have to set it up again, because I believe it did not change right now. Show IP route, yeah, it's directly connected. If we clear PPP all, if we show IP route again, you see this route is learned via IGP. So we disabled this behavior, and now this route is learned via IGP. And now we should be able to telnet. Can we trace? We can trace. Can we telnet? Yes, we can. Okay, the problem solved, and I have to enable link again between 2 and 5. Probably let's verify one more time. seems fine. This one is fixed. Okay, let's go to ticket 5. When connected from R6 to R3, making sure to take paths R6, R4, R3. Okay. So we won't do this. We want to go like this. Let's check it on this loopback interface. How do we go there now? We telnet to 333. Oh, sorry. Of course we don't telnet. We do traceroute to 3333. And well, right now we are load balancing. Okay. Why do we load balancing? Probably if we show IP route 3333. Okay. We learned 1 from 4 and 1 from 1 is the same metric. Okay, so we will change on our 1 metric here, redistribution metric. If we show run section router, be redistribute rep metric 1. Okay. I will change it to maybe 5. Now redistribute metric and the same thing. The metric 5 and we clear IP route star. Show run section router. Redistribute rep metric 5 subnets route map. Oops, sorry guys, I did it under OSPF. I should not have done it. Okay, because we want to affect rep. Okay, I will change it. If we show run section router, okay, now it's back. We want to change this, of course. Okay. If you show run section router, okay, metric 5. Okay, now we go to R6 and we do trace again. We learn it from 4 only. Okay, if we trace to 4444, oh sorry, 33333. Can't be reached. Let's go to R4, verify what's going on. Can we ping 3333? can we trace? 3333. Okay. Why is there a problem? This is interesting. Well, actually, right now I'm not sure why this is happening. Can we ping? Okay, we are reaching 4. This is interesting. Okay, let's go to R3. If we do what? If we show non-section router. Okay, 3 is OSPF. If we show IP access list, we don't have any. Okay, so this route is announced to OSPF via OSPF to 4. If we do here show IP route 3333. Oh, it seems I know what is the problem. Okay, so from R6 we can reach 4 and R4 can't reach 3, but probably R3 does not know anything about this interface. Let's check this. If you do show IP route 10.1.46.6, we learn it from 5. Okay, if we do trace to 10.1.46.6. Oh, so we are looping. Let me verify what kind of loop is it. Okay, so it seems that we found the problem. So from 3 we want to reach this interface, and instead of going in that direction, we go how? We go to 5, 2 and 3. Okay, why is it happening? Well, this route is announced here, then it is redistributed. Okay, because it is redistributed is OE2, then it goes here. Here we have redistribution to EIGRP. Here is 110, here is, it will be 170 because it's external. So this route goes here, and probably because R3 learned about the IGP route earlier, it decided to redistribute it to OSPF, and it also became 110 E2. And now, like, these routes in OSPF domain could choose this route which was redistributed, so effectively causing the loop. I also encountered with this problem where I wanted to solve my ticket, which we'll look later. So, I can't. Sorry, I will reopen the topology. Okay. So, I will just clear IP IGP neighbors on R2. Sorry, guys. Okay. On R2, 3, and 5. 2, 3, and 5, or maybe only on 2 and 3, I will clear IP IGP neighbor, and the same thing on 3, clear IP IGP neighbor. And now this loop, I believe, must be solved. Okay, we can reach. If we now trace route, you go to 4 into 3. So you see that I just reset IGP here, thus flashing this external route. And R3 learned about this route via OSPF, so it won't install it as IGP. Okay, this is not, of course, the best solution, because depending on the order of loading routers, it could still cause a problem. So I will show you better solution later. We will solve another ticket. The best thing, how can we solve this? Here on redistribution, we will all routes from OSPF we will tag, and here we will drop routes with this tag, and the same thing from routes from IGP to OSPF. So we will do tagging in like 2 ways. Okay, if we do it again, we go to 4 and 3. So it seems that we solved this ticket. Okay, check. Okay, let's go to the next one. This is already my ticket. R5 should go to 77.77.77.1 via pass from R5 we go to 3 to 2 to 1 to 4 to 6 and to 7, like this. So this one is not very complicated, but it could be, depending on like if we will have problems with loops or not, because when I tried to solve it I had problems. So let's check. No, let me leave this ticket for a moment, and we go to 7 and verify if we can reach all IP addresses. So make sure that all IP addresses in the network are reachable from all devices, including these routes that we blocked in ticket 2 on R6. Okay, for that we need to create TCL script gathering all IP addresses in the network. How can we do that? So it's really not that hard. So we'll use the same TCL script, and I will add IP addresses. Let me do end on all of them, and I will add R7 because I don't want to gather IP addresses manually. Okay. Gather IP addresses we can using show IP ls. and I will just copy paste these IP addresses in my DCL script. Well, we don't have access using tickets to R7, but I'm a little bit lazy. I don't want to type these IP addresses manually, so I went to R7. Okay. So we gathered all IP addresses. Now let's do our TCL script. Okay. Everything is fine here. The only problem is on R6, because these 55 networks we disabled on stage 2. Okay. But you see that there is, like here, statement that we still have to able to ping them. How? I will show you after we solve this ticket. So, but right now I just checking if our connectivity is alright or not. So it's not like final solution. Just checking before we go to R6 because we could introduce a lot of different problems. Okay, so it seems that everything is alright except odd prefixes, only on R6. So this is good result. Okay, okay, let's go to ticket 6. Ticket 6. And we do trace 77.1. Oh, sorry, not from R6, from R5. Okay, we go. How we go now? Okay, we go to 2 to 3 to 4 to 6 to 7. Okay, so let's solve like this first segment. We want to go to R3 instead of R2. How can we do that? Well, it's not that hard. So on R5, let's do show IP IGP topology for 77.1. Yes. /32. Okay, we learned both routes, so the difference is only in the metric. On Ethernet there is low metric, here we have very high metric. Well, it's mainly because minimum bandwidth is here very low, and total delay is also very low. Okay, how can we solve this? On R3 we should change our distribution metric. If you do show round section router, so this metric should be changed. Okay. Oh guys, sorry, I forgot. Here is 5, of course. Okay. Sorry, this metric. This is router 3. on R3. We give it 200 kilobits per second, 1 delay, 255 reliability, 50 MTU. We also will have to change delay on serial link. If we on R5, if we do show interface serial 1.2, delay here is 20,000 microseconds, and here you see that from router 2 total delay is much lower, so we have to change delay on serial interface. And we do on R5 what? Interface serial 1.2 delay 1. Okay, let's apply this. Okay. 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 Now you see that this metric from serial is lower than this one, and if we show IP route for 77.1, indeed we learn it from 3. If we do trace to 3 to 77.1, okay. Now we go from 5 to 3. From 5 to 3. To 4 to 6 to 7. Okay, now I want to go like this, so we will here increase OSPF cost. Let's go to R3, and if we show IP OSPF interface is brief, we have on this Ethernet interfaces cost of 10, and I will change it to maybe 200. Okay, how can I do that? On R3 we need only interfaces to 4. Interface POSPF cost 200. Okay. On R3. If we do trace again, oh sorry, of course I have to do it from. Now we go to 3. 2, 1, 4, 6, 7. Okay, so it seems that we solved this ticket, but curious about R1. Why we prefer route to R4? Show IP route 77.1. We prefer route to 4. via OSPF instead of RIP. Okay, so this one a little bit tricky, because when I tried to solve it, I had behavior like this. Well, and as I told you, it really like depends on order of operation, who learned route first via RIP. So sometimes it could go this way, so we want to force going that way. Why is it happening? So like we learned this route via RIP 120 and here 120. So this one comes here is OSPF E2 110. This route is now preferable, but it could happen in another direction as well. So like if this route learned first and redistributed here, and it could be learned like this. So let me try to simulate this problem. Clear IP route star. And I want to do okay, now it's even worse. Let me show you. Now it's a loop. Yeah, now it's a loop. So I cleared routes here, and now R1 is going in the wrong direction to 3, 2 and 5. Like 2, 5, 3, 2, 5, 3. So it's going like this. It is so because in IGP domain we already had this route and we redistributed it on SPF, it coming to R2 and it redistributed again, and it's endless. So probably I really want to solve this problem because it's really bad. So let's solve it with tagging tag. And I'll get this my tagging from the ticket one. I will modify it. So we have IGP to SPF. Oh, okay. And we take it like this. Okay. Route map IGP to SPF. IGP. Okay, I want to do tagging in both directions. So, okay, the logic. If we redistribute from IGP to SPF, we permit and set tag 30. If we redistribute from OSPF to IGP, we deny all routes with tag 30 and we permit everything else. Well, what about if you want to do the same thing for another direction? So we have to change here a little bit. I will add here deny, here will be 20 and we match tag 40. Okay, now if you go to Okay, route map EIGRP. Okay, now if we going from EIGRP to SPF, we will match tag 20 and we will deny these routes. So when we going from OSPF to IGRP, we have to set this tag. If we set here tag 40, now it should work. We have to do it on two routers. So let me do this, show run section router, and on RV show run section router. Uh, route map OSPF to EIGRP. We don't care about this redistribute connected. And here we add route map EIGRP to OSPF. Okay, and on R3 we do the same thing. Okay, and we apply this to 3, and we apply this 2. Now on 2 we do this one. On 3 we do this one. And now I believe we want this. We won't have this problem. I hope so. If we do trace route again. Okay, now we go to 467. 467. If I repeat my clear IP route star on R1, okay. I actually don't remember rules. How can we like redistribute the same prefix? Who wins like this, R1 or R4, redistributing the 3 routes? But let me go to R5. We go in the we go in the right direction. But here I really want to make sure that this route, okay, tagging we set, it's working. This route on R4 should be always learned via RIP with ID 100 versus here 100 OSPF. So I just, right now it's working, but it could be that it won't work. So I want to force this behavior. For that we need to change we have to change administrative distance for that route. Okay, let's go to R4. We go to conft router rep, and we do distance 109, source address 10.1.46.6 0000, and I can only define access list. Okay, access list should work. And R777. Okay. If we now do IP access list standard R777, and if we permit 77.1. Okay. And if we show IP route, okay. I'm not sure why all routes from 46.6 all routes are now preferred. Show run section router or access list. Show access list. Yeah, I don't remember exactly how this distance per prefix works in RIP. Let me do this one more time. Okay. Wow, and you actually can see now the problem that I was talking about. You see now I cleared IP routing table, and now R2 won like this battle. So R1 ran these routes via RIP and redistributed them. They came to R6 with administrative distance 110, and RIP routes are moved out from the routing table. But you see here that this route is always here in the routing table. So this is good. If I do clear IP route star again, and while it does, I will copy this on Let me copy answers. And on R4 we do this and this. Okay, now you see these routes are learned only via OSPF, but this route is okay. Let me check. How do we do trace route now? Trace route. Okay. We go to 3, to 2, to 1, to 4, to 6, to 7, and ticket asks us 5, 3, 2, 1, 4, 6, 7. And just to make sure, for another prefix, .2 we go like 3, 2, 1, 6, 7, like 3, 2, 1, 6, 7. Okay, so it seems very good. So key point here, when you do redistribution in 2 points, please always use tagging. Even if you know that there shouldn't be the problem, just do it. Yeah, it will solve you a lot of problems in the future. Also, when you already have the route map, you can like further adjust it. Well, let's say you want to redistribute some prefixes and don't redistribute others. So you will have already route map and you will just insert statements in it. So this is really good solution. Okay, let's go to the last ticket. Make sure that all IP addresses in the network are reachable. And look at this. Let's go to R6 and try to ping one of these addresses. Well, and of course we can't. Why? Because here we like remove these routes from the routing table. Yeah, if you show IP route, we don't see default route and we don't see these odd prefixes. How can we solve this? Well, we could announce default route in the network, or we could do like summarization to maybe .0/24 here and announce it like here. Well, default route will be easiest solution, probably. Let me try. Okay, let me first verify reachability, what we have right now. But here default route is really simple solution, and okay, all right here, all right here, all right here, all right here, not all right with this prefix. Okay, I will. Okay, the simplest solution here would be announce default route, maybe from, I don't know. It is actually does not really matter from where. Let me do this in OSPF domain. I have to do TCL quit, and on route 1, if you do router OSPF conf t, router OSPF 1 default information originate. Oops. Router OSPF1 default information originate. Okay. And if we go right now to 6, we will have default route, show IP route. Why don't we have default route? Show IP route. Ah, okay, sorry guys. Router OSPF1, because we don't have default route in the routing table, we can't originate it. I do this default information originate always. Okay, it should work. Trace 55, 55, 55, 55.1. Okay, now let's do TCL script again on all routers. Okay, we should be able to ping everything because we have default route. Okay, and we can. But I don't know. I don't really like default route solution here. I will show you. Maybe we already announced default route somewhere. Maybe, you know, maybe R7 announcing default route here. So we won't reach this prefix. So probably a little more complicated but still very good solution will be summarized here. Yeah, instead of doing default route, let's undo what I did. Okay. And I do now. Okay. Okay, let's go to R5 and do summarization. Yeah. But remember that we have to learn like specific prefixes. This means that we can't just like advertise summary, we have to advertise specifics as well. So in IGP this is done using a so-called leak map. And yeah, let me show you how it's done. And I will also do it in the text editor. Okay, on R5 we do this interface E0.0.25 IP summary address IGP 100 I55 55 55.0 255 255 255.0 leak map and name of the route map is leak. Okay, and we will Oops. The same thing on serial 1/2 leak. We also need a route map leak permit 10, and that's it. If we like do it like this, we will announce summary address and all specific routes. Let me apply this on R5. Conf T. Okay, let's go to R2. We show IP route. Okay, you see here we have summary and all the specifics. Let's go to R6, and if we show IP route, well, we still somehow learn this default route, even so. Show run section router. We should not. Oh, sorry. No, router SPF 1. Yeah, should always verify what I do. Okay. Now you see that we are learning .0/24 summary and all the specifics 2, 4, 6, 8, 10. Okay. If we do trace, no, I will just ping 77, 77, 77.1. I can ping. Can I ping 2? I can. Show IP route. Yeah, we still have this default route. I probably should clear routing table for RIP. I will verify until okay, yeah, we don't have default route. Now we should be fine. If we okay, now I will repeat my TCL script. Okay, alright. Okay, seems that we solved this one. Now let me double check several tickets just to make sure that we are good. Okay, make sure that we made sure we already pinged, so these prefixes are indeed reachable. Make sure R6 only learns the even specifics, the even prefixes from R5. If you do show IP route, we'll see here only even. This is fine. If the link between R2 and R5 goes down, make sure that R6 can telnet. Can we telnet now? Telnet 5555. We can. If we disable our link, can we ping now? Telnet, sorry. We can. Okay, this is fine. Oops, shut. Okay, we telnet. Okay, we can. We do no shut. When connecting from R6 to R3, we should able to take pass R6, R4, R3, telnet 3, trace route 3, 3, 3, 3. You go to 4 and 3. And R5 should go to, why is that pass? 7.1. Sorry. Okay. We go to 3 to 2 to 1, 4, 6, 7, and we have to go 5, 3, 2, 1, 4, 6, 7. Okay. So it seems that we solved every ticket. Thus, this is the end of this video tutorial. As always, please be free to leave your comments below, and if you still don't attend Andre webinar session, I strongly advise you to do so, even though for our like CCNA level it's set in this title, but really they're like CCNP plus level, sometimes even CCIE. So please come in, participate. We are always happy to have more participants, especially active ones. So please check the post-webinar discussion thread. And till the next time, see you.